Today we finish up what was sort of a two-part and sort of a four-part series of videos, and we actually come up with our recursively navigated cascading lists that go through a series of directory leaves and look at the last two directories in the leaves to create the cascading lists. And in this series we talked about four generic collections: the queue, the stack, the list, and the dictionary. And the dictionary, actually we haven't talked about the dictionary yet. We're going to talk about it today, but we've talked about the dictionary several times in previous videos. And of these generic collections, we use no less than the last three: stack, list, and direct dictionary. Of course, what makes them generic is the fact that they have angle brackets where you specify a type. So if you say queue int, it operates appropriately on the int type. And if you say queue string, it operates appropriately on the string type, and so on. And all of these are like that. The dictionary actually has two things that are like that: a key value or a key type, and a value type. So you use the key type to look up the value type using the dictionary. The cascading list boxes themselves are actually implemented with combo boxes, which just have one entry and then a drop-down list. And the drop-down style is drop-down list, which basically means it's read-only. You can select from the list and put it in the text box part, but you can't actually type something into the text box part. And another major concept we use in this program, I think for the first time, I don't believe I've used it in any other program I've written so far, is a concept of a break boundary. And basically a break boundary is the idea of having a variable that remembers a state, and then you're in a loop and you're going through data, and you look at the memory variable and you see if you're still in the same state, and you are for a while, and then suddenly something changes and you're in a different state, and at that point that's a break boundary. In a lot of ways life is like a series of jarring break boundaries. In fact, that's sort of why I got into programming. It always struck me as such an excellent analogy or allegory for life. Well, once again we're using a multi-line text box to show the directory leaves we find when we recursively navigate through the directories. And if you don't know how to do that, that's what I describe in great detail in the video right before this one, video 179. And then in addition to that, we have the two combo boxes at the bottom, one for author and one for books. And these are created by going through the directory leaves we find. And we use the generic collections I was talking about in order to implement that in a very efficient way. In fact, it would take a lot of work to figure out another solution without using these excellent generic collections. In the code itself, we call a routine called recursive leaves, which specifies a root directory, and this gets all the directory leaves. I described this function in detail in the previous video. And then we have our memory variable for author, and I initially set that to a value presumably we would never have especially as the first value, since they're sorted alphabetically, of an author that is immediately going to get a break boundary the first record we look at. And then we go through a for each loop, and in addition to showing the leaf directory that we find that we append to the text box, we now call another routine called update cascading lists with the leaf value. And the update cascading lists, we use the split method of the string for the directory we found, the leaf directory, and we break that up into an array that shows all the directories that make up the path to the leaf directory. And then we use another format of initializing a stack. We talked about a stack 2 videos ago, and we used a series of pops in a loop to populate the stack. But you can populate it very directly by just specifying the array to the constructor, and that'll create as a stack all the directory parts we have making up the path to the leaf directory. And then we use the principle of the stack that the last in is the first out, to first pop the book, which is the last directory part of the path, and then pop the author, which is the next to the last part of the directory path. And then we compare the author to our author memory variable, which is initially set to all x's. So that's going to create a break boundary right away. And we set the new author we've found to the current author, and we set the current author to the author memory. So as long as we have this author, we're not going to get another break boundary. So if we have 20 books by the same author, we'll never fall into this if. And then we create an entry in our directory that has the current author as the key and creates a new list of strings as the value, which is a technique, as far as I know, I invented. I'm sure a number of other people have invented it too, which allows you to have a jagged two-dimensional array with authors as the first dimension of the array and a series of books, however many books we have for that author, as the second part of the array. So we put in the author and create a list for the books, and then for that author we add the book. So this will create one entry in the dictionary that has as the key the author and has as the first list value the book. And then when we go through with other authors that are with other records that are the same author, we're just going to go to this guy, and we're going to skip over this if, since we haven't got another break boundary, and we'll just keep adding books to the current author until the current author changes, till we hit a break boundary. And then the last thing we do in the form load is we call fill author list, which fills in our first cascading list box. And in order to do that, all we have to do is have a variable that goes through all the dictionary entries of author and book key value pairs, and then just look at the key, since every key is a unique author due to the break boundary we used in populating it. So this will fill the list with alphabetically organized authors, just because of the nature of the way directory structures are organized. And each of them will have one or more book associated with it. And the book array is what the cascading list is, because we select an author, and in the other combo box it'll show all the books written by that author. So let's run this program and see how it works. Compile and run, and almost instantly get a list of all the leaf directories. So the first author is Frank Abagnale. I think I mispronounced his name. The first book is Catch Me If You Can, and there's only one book by him, so we're going to get a break boundary right away and create a new directory entry with a new author. And the same thing for the second one, but when we get to Isaac Asimov, we have a number of books: Caves of Steel, Foundation's Edge, and so on. So we're not going to get a break boundary for this. We're just going to be adding books to the same author in the dictionary at this point for all these guys. And do the same thing through all the different letters: A, B, C. Michael Connolly, probably my favorite mystery writer at this point, and John D. MacDonald is my old favorite, but unfortunately he died after writing 21 really excellent Travis McGee books. Here's MacDonald. So we'll get like 21 records with the same author in the dictionary structure when we hit this guy. And we've actually already created the cascading list, because I do that also in the form load. So if we do the drop down for author, you'll see all the authors, or I hope you're seeing them. It looks like it goes in front of my recorder, but hopefully not. And then say we select the guy we've just been talking about, John D. MacDonald, and then go to this cascading list, and we'll see all the books that MacDonald wrote, at least all the ones that I've read, which are the Travis McGee's. They all have a color in the name, like the Deep Blue Goodbye, Nightmare in Pink, and so on. Well, to see how we implement this cascading, we need to look at the default event handler for the primary list box, which is actually a combo box. And if I double click on that, it'll take us to the CBX primary selected index change. So anytime you select a new author, you'll get a selected index changed event. And this utilizes the dictionary structure once again. If we look at the definition of the dictionary structure, it's dictionary string, and then the second value type is list of strings. And the name of it, of course, is book, and then new dictionary string list of strings to instantiate it. This, of course, calls the constructor. And then we also have our list of leaves for the directory, which looks at each directory path individually, which is a list with a string type, and the name leaves and new list string type. And of course the cascading generic collection is defined in the update cascading list with a stack and the name aspect. And this will, we've already broken up each of the prongs of the path, each directory, individual subdirectory within the path, into an array of strings called prongs. And this puts these all on the stack. I remember I said that we populated this previously with pops. Of course that's incorrect. You populate a stack with pushes, and you take items off the stack with pops. But if we look at our primary index change, basically what it does is it gets the selected author via the combo box selected item converted to string, and puts that into selected author. And then we clear out the secondary list box or combo box, and we go with a loop through all the books that are in the directory or the dictionary item with that selected author key. So if we have Isaac Asimov, we'll get all the books by Isaac Asimov as a selected author, or John D. MacDonald, we'll get all the books by John D. MacDonald, and so on. And then we just use a combo box items add to add each of these author books in turn to the secondary list. Well, I hope you enjoyed this tutorial and learned a lot, and I'd appreciate it if you'd subscribe.